Welcome students, welcome to part 5 of chapter 2 structure of atom. In last video we have discussed about Rutherford model of atom and some terms related to its model of atom. In this video we have discussed about the Bohr model of atom and its achievements. So as the Niels Bohr just make some modification in Rutherford model of atom and presented as the Bohr model of atom. So he just concluded various results of interaction of radiations. He take the different atoms or different material or matter and make their utilization in the interaction of various radiations to improve the Rutherford model of atom. According to him, whenever the matter is supposed to remove or eject or emit the radiations, so these radiations may be of different characteristics. According to him, he made two main development in his model of atom. The very first one is the matter is if emit the radiations composed of two type of behavior, means the dual character of electromagnetic radiations, which means that the radiations possess both wave-like nature as well as the particle-like nature. Means whenever the particle is moving, or suppose when electron is moving around the nucleus, it shows the dual nature. That means it shows a wave-like nature, means it moves like a wave which needs no medium material to travel, as well as the particle-like behavior. So this is the dual behavior which was the result of studies of Niels Bohr whenever he was studying about the different nature of the radiations. Second thing is the experimental results regarding the atomic spectra. So whenever he just reading the various spectra of various atoms, he concluded that the quantized electronic energy levels are present, means whenever the electrons are surrounded around the nucleus of an atom, so they possess some energy in forms of the quanta or the quantum. So these quanta are the small packets of energy which is carried out by the electrons, and by taking this energy the electrons are revolving on the nucleus. For example, if you are taking this one is the nucleus and this is the orbit of the atom, so the electrons are present around the nucleus having certain energy, and this energy is present in terms of photons. Photons is the smallest unit of energy in terms of quantum or quanta, which is studied under the quantum mechanics. So these two observations or these two modifications will help to understand the Bohr model of atom. So the very first one is the wave nature of electromagnetic radiation, which is called earlier as the wave nature of the particle. So according to him, when electricity or electrically charged particles move with continuous acceleration, suppose when this particle is moving in an electrical field, so what happens? Whenever this particle is moving, so it is produce some electrical and magnetic field and produce as well as the transmitted. So what happens whenever this electron is moving, because it is electrically charged already, whenever the electrical charged particle is moving, so it produces some amount of electric energy as well as some amount of magnetic energy, which is produced as well as transmitted to the next medium. So this is the very first observation when he just studied about the wave nature of the particle. So this concept was first explained by James Maxwell. So according to him, when a particle is moving, it produces the two fields, that is electrical and magnetic field. And what happens whenever these two fields are generated and the particles are still moving, it is called as electromagnetic wave, because it produces two type of fields, electric field as well as magnetic field, and this is moved in such kind of wave motion. That's why it is also termed as electromagnetic waves. And James Maxwell was the first scientist which tells us about the dual nature of the light. Because earlier it was think that the light is only a particle which is moved in a medium, but James Maxwell proved that the light consisting of dual behavior as wave nature as well as the particle nature. So this is what the electromagnetic radiations concept in terms of as explained by James Maxwell. But what is the property of these electromagnetic radiations or EM waves or EM radiations? So very first property is that these radiations consist of electric and magnetic field. As I told you, whenever any electrical particles or electrical charged particles is moving, it produces the electric field as well as magnetic field. So whenever these radiations consist of electric and magnetic field, so these are oscillating perpendicular to each other. Suppose this is what I am representing as the three axes. That is, this axis is called as x-axis, around which the waves are oscillating, and this is the second wave, that is y, which is representing the magnetic field lines, and third one is z-axis, which is representing the electrical field. So whenever the electric and magnetic field oscillating, so this is what the electrical field, and the black dotted line is known as what? The magnetic field. So whenever these two magnetic fields are oscillating, which is mutually perpendicular to one another, so what happens? These two are again mutually perpendicular to the propagation in which it is propagating, or the medium. So the radiation consists of electric and magnetic field oscillating perpendicular to each other and both perpendicular to the direction of propagation. So whenever we are studying about this one, suppose we have three dimension figure, it is represented as x, it is y, and it is z. So first wave is moving in z axis, second moving in x axis. So these two are mutually perpendicular, and this is what this is the direction of propagation in which it is moving. So these three are mutually perpendicular, like that. If we just take this one, this is one direction, this is second direction, this is third direction. These three are mutually perpendicular to each other. And suppose it is electrical lines and this is magnetical lines. So these two are mutually perpendicular to each other, as well as these two are perpendicular to the third one, that is direction of propagation. So this is what the first property of electromagnetic radiation. The second one is what? That these waves or radiations do not require any medium material, because it was studied that the waves do not require any medium material to travel. That's why it is said that these waves or these radiations do not require any medium material. The third one is these radiations possess the wave character and travels with the velocity that is equal to the velocity of the light, that is 3 into 10 to the power 8 meter per second, due to which these are also known as electromagnetic waves or electromagnetic radiations, because as we know, the electromagnetic waves are produced when the charged particles are moving, as a result of which these two fields are produced, and whenever the particles are moving with the velocity of light, therefore it is called what? Electromagnetic radiations. And as we know that whenever the waves are produced, so the waves can be characterized by their wavelength as well as their frequency. So in terms of which the waves or the radiations are of various types which differ from one another in wavelength as well as frequency. So this is the difference between the various kind of waves, whether it is your electromagnetic waves or is your any waves, light waves or any waves. So these waves may differ from one another in terms of wavelength, frequency, and many more terms related to the wavelength. Related to the wave. So this is what the properties of electromagnetic radiations or electromagnetic waves. Some common terms related to waves we will study in the next part. Okay, thank you. If you have any doubt, then ask me in your comment section. Thank you.